So, Gears and Gear finally has a lathe. As you can see, um, I ended up buying a used lathe off of eBay. This is a Harrison M300. It's probably I don't know, the VW Golf of lathes. It's basically a Colchester student in disguise. So, nice British-made machine. Got it for what I consider to be a fair price from here. It spent about a week in traffic, uh, in transit basically. Customs, although I'm in Europe, there shouldn't be any customs, was expecting some sort of paperwork telling me that, I should pay import taxes or whatever on this thing, but I'm a private individual, so that didn't apply. So I sorted that out with the seller. Lathe was in my driveway here basically the second day, I think. Moving inside here, inside the workshop, well, that's a different story. This behemoth, well, it's not actually a behemoth, it's a pretty small lathe. It's only 13 inches swing, 330 millimeters, and 600 and something millimeters between centers. This thing still weighs about 600 kilos, which is not an insignificant amount. Well, honestly, that's what I was kind of looking for. A stout machine. The bed is really thick and wide. It's got very thick ribs. And as you can see, so just the sheer thickness of this might be, I don't know, 80 millimeters across for that rib. The lathe came in surprisingly good condition. The ways are perfect. I mean, you can still see machining marks on the cross slide. I haven't really touched the top slide because I didn't need to. The gearbox feels perfect. Bearings are perfect. There is no measurable run out on the spindle nose. I got my half micron dial test indicator, put it on the spindle, barely read anything. I think it was just noise of the spindle, basically the imperfections in the surface of the spindle itself. It shifts nice and easy through all the gears. None of the gears are noisy, none of the gear sets mesh poorly. It did, however, have one problem, which is basically the bane of the existence of all these lathes. In here, especially for this knob here, this knob drives a bevel gear set that drives a set of cams. They're made of plastic, and those cams move some dogs that select some gear ratios in the feed box. So this is the feed box. When I got the lathe, that cam was like that knob on the bottom was seized, completely seized. It was immovable, and it involved, so I had to take off the feed box, basically the lead screw, the power feed, the bar, it's hex bar here, which entails a lot of maneuvering the saddle back and forth so you can extricate the screw and stuff like that. It means messing around with that end as well. You need to take out the thrust bearing that holds this still. It was a whole can of worms. I managed to dig this thing out, clean it with diesel, take apart the mechanism that wasn't working. Then I put it back together, which was a whole ordeal because I don't have the manual for the machine, so I could only reference how the cams were supposed to go back in via another YouTube video, and it was very, very hard to follow. But anyway, in the end, I did try threading and feeding, power feeding, as you just saw. And if you set it to a 1 millimeter pitch, it cuts a 1 millimeter pitch, which is bang on. Now, the seller was nice enough to refund the part of the money that I spent on the lathe for this issue because he didn't know of it. So yeah, the experience with the seller was really, really nice. I'm gonna leave a link in there if you want to get the machine tool and you're in Europe. This guy's got some pretty cool stuff in stock, and he's really nice, and he delivers basically. Like, I have no idea where you would go to buy used machinery. He handled transport, he handled everything. And that was my main concern because, okay, if you buy a new machine, I was looking at a Damato Machine thing. If you buy a new machine, they're going to deliver it to you, but the machines that are in the price range of what I paid for this are all import. So I didn't want an import machine. I wanted something that I could, use for a while and that would have little to no wear and, so this is, as I said, it's a Colchester Student 2500 in disguise. It's a Harrison M300. You can barely make out that it says Harrison there. 330 millimeter swing, 600 millimeters between centers. It's got this nice chip splash guard. It's got a coolant pump. It's got a 2.2 kilowatt motor on it. 3-phase asynchronous, of course. It does pretty much all the threads and feed pitches, inch metric, everything. This is a metric machine. You could buy them in both metric and imperial, so it was either 6 millimeter or I think 4 TPI, not entirely sure. 6 millimeter or 6 TPI, sorry. For the lead screw, dials all read in metric. They're direct readings, so what you read is that what you're actually taking off of the diameter. Power feed in both directions, and yeah. This thing runs in gamma bearings, which are really nice. Gamma bearings are, I think, still kind of the most accurate bearings in the world. It's got a dual, it's got a matched pair in the front and a single row angular contact in the back. Yeah. Okay, let me just reposition and tell you a story. Okay, so a while back, I used to have one of those Proxxon PD 400, I think, benchtop lathes. There's a review video about it on my channel. I think it's one of the first videos that I ever put out. And I got absolutely flamed for that review, saying that it was a crap quality machine. People were telling me that I have no idea about how to turn or how to machine in general or anything. And they're telling me that no, it's a good machine. You're just a moron. Okay, fair enough. I might just be a moron, but there's two caveats to that. First of all, I was talking about the lathe that I had. So the PD 400 that I had came from the factory with a broken casting in the bed. Basically nothing on the machine fit properly from the get-go. The gives were so loose that he could pick up the top slide or the cross slide by 0.5 millimeter without even breaking a sweat. So he could lift it by 0.5 millimeter, and I had to go through all of the adjustments 10 or 20 times until I got it to sort of work. And then the machine had basically no rigidity. Because of the crack in the bed could shift. The ways would shift one in reference to the other. And anytime you tried to part off to take a cut or to do anything like that, it would just, pull the tool holder inside beneath the spindle and, just break tools. generally do all sorts of rubbish and endanger the operator. So I stand by my claim that that machine was horrible. Now, the Proxxon PD400 itself might be a good lathe. There's one that we have at work that is about 10 years old and that still makes good parts. With the same caveats, it's got no rigidity, but not a cracked bed this time. That machine has no rigidity. The ways aren't hardened or ground, so anytime you drop something on them, which on a small lathe when you're trying to work around small bits happens, and if you drop one of these tool holders, you're going to have a ding in the bed. And it doesn't have feeds, of course. It only has power feed if you want to screw around with the change gears in the back. And cutting threads is a nightmare, etc., etc. So, and the nail in the coffin for this entire analogy and discussion that I'm trying here is that Proxxon cost about 80% of what I paid for this. Now, okay, the Proxxon was, usable in an apartment without, ruining the floors or anything like that. So this wouldn't even be supported by a regular apartment. But now, since I don't have the problem with concrete beneath me, the fact that a Proxxon claims to be a lathe that can comfortably turn small steel parts is just nonsense. And I hope this time around I'm clear enough when I'm saying that. They're fine machines for hobbies, for modeling. You can turn small parts in steel, but you have to baby the machine. You have to be very careful not to push it, because it might seem that it can let you get away with something, but it won't. In the long term, you're just ruining the machine. Whereas something like this, which again only cost about 30-40% more, actually not even that, 20% more, if you look out for them, you'll find one, and is just a whole different class. So this can actually turn straight, it can turn to tolerance, it can turn better because it has power feed, it can do so much more. So I have really no idea why people still go for small bench machines when they have space for something like this. I'm gonna get flamed again for this opinion, but it's only an opinion, and this is, you do what you want to do with your money. Get a Chinese mini lathe, do whatever you want. As long as you make good parts on it and you're not killing the machine, go for it. But my advice is you stay away from the newer made Proxxons. Having a cracked bed in a machine from the factory that apparently went through quality checks and testing and stuff like that is just unacceptable. Okay, let me reposition so I don't bore you with the same angle, and we can talk about the electrics. So being an industrial machine, this thing has a 3-phase 400 volts 2.2 kilowatt AC motor inside, an induction motor basically. And I don't have 3-phase here, but there is a way you can get around that, because it only consumes at most 2.2 kilowatts. You can kind of sort of run it off of a regular circuit, a 16 amp circuit, without too much worries, if you don't really push it all the time. So I think with the losses of the inverter and the motor efficiency and stuff like that, I think that a 16 amp circuit is plenty enough for this machine. I spent quite a long time thinking about it. I was expecting that running 3-phase to this place would be easier. Well, it's not really easy, but it will take some time. And when I do get 3-phase in here, I intend to restore this lathe to its original configuration with the control panel that it came with. But in order to get some use out of it in the meantime, and to actually have some horsepower available behind it. Remember, 2.2 kilowatts is almost 3 horsepower. So I installed a couple of inverters, one for the spindle and one for the coolant pump. Both work fine now after I've sorted out the bugs. Spindle runs in both directions. You can hear just how nice and smooth that headstock runs. It's a simple oil splash bath inside, but it's perfect. And it only takes 1 liter of hydraulic oil, and the oil inside was crystal clear when I took it apart to check it. And the gears look perfect, everything as I said. So I got 2 inverters. One is feeding the coolant pump, which I don't want to turn on because it's kind of a mess. I'll insert a clip around here to show you that it's actually working. And one of them is powering the main spindle motor. There is a problem if you want to do that. So when you take an inverter and it runs on line voltage, like regular 220 volts, 235 technically, that inverter can only output about 235 volts RMS per phase, between 2 phases actually. So a line-to-line voltage of 230 volts RMS. Now these motors, because they're meant to run at 400 volts, they expect 400 volts line-to-line, right? So what you need to do, which is not an easy feat on this machine, is take the motor and wire it from Y to delta. Let me take you over to the whiteboard and show you what that means. Right, so these are the 2 configurations in which a standard European asynchronous motor can be run. Sorry. American motors are usually a bit different. They have series parallel windings. In Euroland, we kind of have Y and delta. So inside the motors, you have 3 windings, which have both ends exposed. And they sort of usually do it like that. So this is U, V, and W. These are usually the names for the windings. And this is U1, U2, W1, W2, and V1, V2, right? So they're usually something like this in the motor housing. When you take the cap off a motor, you have U1, V1, W1, V2, W2, U2. And why is it like that? Because you can either tie it in Y by strapping along this line, which exposes, so this leaves you the central terminal here and leaves the 3 ends, right? Or you could bridge across here like that, and it gives you this configuration. Now, what happens if you run a motor? So to make sure that this horse is completely dead, this is the high voltage wiring for an asynchronous motor. This is the low voltage. This one, for a regular motor, expects 230 volts-ish across the phase. This one expects about 400. Now, what happens if you run a motor that's wired like this on the voltage, like intended for this configuration? Well, you get, basically, to cut a very long story short, you get 1/3 of the torque. So you cannot expect a motor to perform, any way near optimally if you run it with this voltage on this wiring. So you need to take apart a motor and wire it in the correct configuration. I have another small motor. I can take it apart and show you what I mean. Okay, so as you can see here, I ignored the incorrect colors for the wiring. There's the ends of the windings exposed, and this motor is right now configured to run as a Y configuration. So you have the three of ends of the windings are bridged together, and you're left with the exposed ends, which are connected to the supply, which in this case was an inverter again, of course, but yeah. One thing to note, again, about motors, for an asynchronous motor, if you want to make it go around the other way, you just flip two of the phases together, and that makes it spin the other way around. Now, if you'd want to take this motor and configure it from Y to delta, you just undo these nuts, and you have three straps here. They provide you three, two of them are bridged on the same side because, you know, convenience, and you just wire them across. And that's how you get your Y to delta wiring, right? Simple enough. Okay, let's get back to the lathe. Now I'm gonna have to apologize for the state of the wiring. It's a complete mess. I did reuse the original backing plate and some of the hardware. So these connection blocks in here and stuff like that. This is all very temporary. You know, the most temporary solutions are the longest living ones. So anything's temporary until it becomes permanent. So this is the inverter for the pump, and that's the inverter for the spindle. Funny enough, this is actually a 3 kilowatt inverter. This is a 120 watt inverter, and this was about 40% of the price of this one, which is absolutely insane. Both of them are mostly empty. So anyway, they're good quality. They're Siemens. They're a nightmare to program. The manual is 300 and something pages long, and setting the parameters is very difficult. You have to navigate through the menu using buttons and this tiny 7-segment display screen here. And for the moment, I'm just using a long extension cord to power the thing. It's not great, I know. I'll deal with it. And the worst thing is that the panel now doesn't close when because of the installed inverters. So if these were actually to the size that they needed to be, which is about this bit here missing, this would have closed no problem. But because there's so much empty space inside for options, so like filters and stuff, I just didn't, it couldn't fit. You couldn't close the door on the electrical panel. The electrical panel from the factory is really simple. It has start and stop in both directions. It has an interlock in the separator, so that dingus here, come on, focus. That is makes you completely disconnect the supply before accessing the panel, which is nice. This is the only thing that stayed in here because, you know, I thought I was gonna be clever and reuse it, but guess what? The panel doesn't close. These are the switches for the forward and reverse, and that's some wiring for the e-stop up top. I don't really need the e-stop right now because I have the brake wired, so the brake just interrupts one of the connections of the forward. So if you step on the brake pedal, the inverter disconnects, lets the motor coast down, and the brake mechanically stops it in very, very quick order. It's handy, and I think on a lathe it's a bit more useful to have the brake as an e-stop than an e-stop in particular, because no matter what you do, your legs are bound to be on the ground, and your hands might be somewhere else. Okay, that brings me to a very important point. Let's get back to the lathe top. Be right back. So in my opinion, lathes are amongst the safest machines out there. As you can see, this one doesn't have a chuck guard. It doesn't have covers or anything. There was a version of this lathe that you can buy called the T300, which was a training lathe, and it had all sorts of covers everywhere. And I don't think that's necessary, because lathes are, although very dangerous, they are obviously dangerous in every respect but one. So let me just show you. If I put the lathe in its lowest speed and actually turn it on, the chuck doesn't seem that dangerous, right? It's turning very slowly. You can see that it's turning. It's not making noise. It's not throwing stuff at you. It's fine. But this is the most dangerous situation in which you can operate a lathe. Because it's turning so slowly, it has an inordinate amount of torque behind it. So everything you put near this, the lathe won't even feel it. So chuck key in the chuck, it will just rip it in half, destroy something, grab you with it, or do some other horrible stuff like that. Lathes, when spinning fast, are obviously scary and dangerous, and usually are relatively easy to avoid. So if I put it up to 800 RPMs, this is 180 RPMs, sorry. This is 800 RPMs. Now you can see it's dangerous, right? It spins fast. It's making a lot more noise than it used to. It's blowing some wind off of it as well, so it's inherently self-warning. So it warns you about the fact that it's a dangerous machine. But if it's spinning slowly, it's got 1,000,000 Newton meters of torque behind it, and you won't realize when you get ended. So not only will this end you, but it will hurt the whole time you're being ended. Now that we've dealt with that ray of sunshine, which I had to make sure that you understand, lathes are the safest machines in my opinion. Mills are far more grabby, bitey, pinchy and stuff like that. There's no real way of you pinching your fingers in this machine. If you keep your hands where they're supposed to be and don't touch this while it's spinning, no matter how tempting it might be, especially if you come from a small lathe, a bench lathe, hobby lathe, or something like that. I've seen people stop the chuck while it's spinning by putting their hand on it. Well, this will rip your arm off if you do that. Treat it with respect. Keep your hands where they're supposed to be. The controls are clearly labeled. They're far away from the stuff that you shouldn't be touching. So there's no real way of getting yourself injured with one of these if you take care. One thing that I must insist on is eye protection. A mate of mine at some point ago was turning some stainless, and apparently he was turning it very poorly, or the lathe he was turning it on wasn't very great, or the tool wasn't great, or his feeds and speeds were wrong, because of course it threw a giant rat's nest. And one of the rat's nest of stainless steel sliced his face open, missing his eye by less than 10 millimeters. And he had to get stitches, and he had a busted lower eyelid, and that's all because he wasn't wearing eye protection. Yeah, you can be like, it's not gonna happen to me. I can always dodge the chips. No, you cannot. They move far too fast for you to be able to dodge them. So, lathe safety out of the way. Let me tell you about lathes in general for a second. Maybe not all of you know what lathes are and what they're supposed to do and what the major parts of the lathes are. So, this is the lathe bed. This is the headstock. This is the feed box. This is the lead screw, and this is the power bar or something like that. This is the saddle The saddle runs on the ways, which are on the lathe bed. This is the apron. This is where the magic for feeding and screw cutting happens. This is the top cross slide, because it moves crosswise to the lathe axis. And this is the top slide. This is the bit you move around if you want to cut threads the correct way. This is a chuck. 3-jaw chuck is what the lathe came with. Not the best choice. I prefer a 4-jaw. It's on the short list for, equipping this lathe. But it's good enough. I can tap it in to make it run true, like below a 1/10 of a millimeter. Usually I can get it within 50 microns, which is decent. There's obviously a looser chuck jaw than the rest, but if you tap it and fiddle around with the tightening screws, it's fine. This is the tool post. This is where you mount your tools. The tool tip has to be on the center line of the lathe. And another important thing, you should always make sure that the piece you're holding isn't too far out of whack with respect to its thickness. So you wouldn't put a 1/2 meter long bar of 20 millimeter diameter steel or something, because when you try to cut the long end, it will sound like crap and it won't cut. There won't be enough rigidity in the bar, even though the lathe would be plenty rigid. That is the tailstock. The tailstock has a quill, not unlike a drill press, only that this quill is operated by a hand wheel, and it's got a nice big girthy thread in there and a Morse taper, where you can mount centers or chucks, drill chucks or stuff like that. And on a lathe, this is the z-axis. Moving towards the z-axis is z positive, and this is the x-axis. So, and x-axis is positive towards yourself. So the further you go in, it's negative. The further you go out, it's positive. And that's about it for lathes. I believe that anybody should really have an idea about how to use a lathe. Lathes are the most beautiful machines in the world, I think. I think there's nothing prettier machine tool-wise than a lathe. They're just, I don't know, there's something oddly satisfying about seeing a piece of metal being turned into a perfect cylinder or a cone or something, and chips shearing off of it, and the sounds that these things make, and the general feel. It's such a tactile machine. Every one of these knobs is just so pleasant to touch and work with, and yeah. And I'm really happy to finally have one. It's been a long dream of mine to have a proper lathe, and such a good quality one at that. So this is a English-made lathe. There's been like 1 million of them made in total, I think even more. And I think you can still buy this exact model. So if you have like 50 grand to spare, my assumption is that that's what they would go for in today's money. So pretty good, solid investment. I can turn stuff. Oh, I've already turned a lot of stuff on this lathe, mostly heads. Okay, I'm gonna go. Couldn't resist that. It was stronger than me. But I really didn't do anything on it yet. Moving it in, getting it connected to power and leveling it, and doing all the necessary maintenance on it to get it working perfectly has just taken a very, very long time. So next time I have a cylindrical-ish part to make, of course you're going to be the first to see it. But that's a quick overview of my new lathe. So again, thanks to Romano, who sold it to me. If you need machine tools, go check him out. He's got a pretty nice website, and he always gets new machines. If the stars align, I might be getting something else from him as well. I don't want to jinx myself, but it's green, it's pretty big, and it's made in Switzerland, so you know it's good. So that's pretty much about it. I have nothing else to tell you about the lathe at this moment. Once I get more tooling and stuff for it, I'll be sure to update you guys. Oh, and there's one more thing, and feel free to skip because it's not part of the video. I've been looking at, so I don't watch shorts. I don't watch YouTube shorts because I consider them an affront to my already fading, you know, attention span. So my attention span is like less than goldfish at some point. So shorts usually do only bad things to my attention span, right? And I posted some shorts and they got like 4,000 or 5,000 views on YouTube. And there were 10-second clips about, I don't know, one of them was a facing cut on the lathe and one of them was something that I machined on the CNC. I think you've already seen them, maybe. Why is the algorithm so hell-bent on ruining people's attention span? I can never understand. I think the engagement and the way that the engagement is defined and maintained in this platform is very toxic. And yeah, I don't know. Anyway, thanks for watching, guys. I hope you enjoyed this. A first look at my Harrison M300. Here's to using it for many years and making a lot of parts with it. And thank you for watching and have a great day. Bye.